Hello, everybody. Good afternoon for me right now. But I don't know when you're watching this. But let's get started. Let's continue our exploration of trigonometric functions, and more specifically with angles that are acute angles, right? Really nice, cute little angles that are less than 90 degree. Yeah, I'm gonna continue using that one. I did warn you. All right. So one of the assignments was for you to do the reading on calculator and how to make sure that your calculator, when you're dealing with trigonometric functions, changes from the modes, degrees or radians. So be careful with those. Keep those in mind when we're using these ones. Um, such that your answer is given in the right unit, and you can easily do the conversion also if you need to. But let's go and see what is cosine of 30 degrees. So remember how we started building these properties and measurements. So cosine of 30 degree, if you put it in your calculator, the answer should be point a. This is not working. 0.8660 blah 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 blah. But what is the actual value? This is an approximation. What is the actual value? Well, for that, we see how we built that angle. We said we'll start with an equilateral triangle. If it's equilateral, then this one would also be 60 degrees, which is equiangular. Now we have, if this was 60 degrees and we cut it in half, then this is 30 degrees. If this is 30 degrees, and everything was 2 around and it cut it in half, that means that this is 1. So it results in this really nice right triangle of measurements 1 with hypotenuse 2, and we're referring to this angle theta. And what is this? Well, this will be square root of 3 by using the Pythagorean theorem. So if we are asking what is cosine of 30, well, so Toa says the cosine of 30 degrees is going to be equal to adjacent. If we look at this one, according to my angle, what is my adjacent? Square root of 3 over my hypotenuse, which is 2, which it is the exact value. And now, from there, we move on to this example. Solving for the right triangle. What do they mean when they say solve for a right triangle? They pretty much want you to find all the measurements for all the missing sides or missing angles that there might be. So most of the time, either you're going to have to use Pythagorean theorem, or you could start using these trigonometric ratios as well to get all these answers. So let's see, how can we do this? And it's important for you to always be able to see your angle and where are your sides of your triangle in relation to this angle that you're interested in. The one trick that always works for me is I always find the hypotenuse first, hypotenuse, 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 and then I go from there. So in this one, they want us to solve this triangle, which means find the other missing angle. In this case, we have the missing angle right here, and we have A. We don't know what A is, and we don't know what B is. It is a right triangle, so we can use that information to find the missing angle. We know that there is 90 plus 37 plus, I don't know what that might be, and the total is 180 degrees. And if we do that, then we end up that x value is equal to 53 degrees. So we just solve for this angle. This angle is 53 degrees. Now we're just missing the side. What is A or what is B? And notice that here we really do not have any other things to solve using the Pythagorean theorem. So we are forced to use these trigonometric ratios. And here's where you need to be careful which side are you choosing and how you're choosing it. At least I always stop and pause and think first. So I'm always thinking about this angle of 37 degrees. I'm free to use any trigonometric ratio, sine, cosine, or tangent, but I do need to use the right side labeling. So in this case, let's say that I'm interested in finding A. So let's find A. Well, in order to find A, I need to understand what is A in relation to the angle. Well, A is opposite from the angle. And then I need to use a measurement. I cannot choose B because then I have nothing to work with numerically. So then I choose the hypotenuse. So I have an unknown and I have a known. So what did I have to use then? From 37 to find A, I had to use the opposite and I had to use the hypotenuse. So if I go here, where do I have opposite and where hypotenuse? Well, that is sine. So then I say sine of 37 degrees is equal to opposite. Opposite is A over hypotenuse, which is 8. And we're interested in finding A. Remember the size of A? Well, here, if we want to leave A by itself, we have to multiply by 8. And it turns out that A is equal to 8 times sine of 37 degrees. If we use a calculator for this one, we end up that this is approximately, not equal, that is a horrible approximation sign. Approximately, not that this one is any better, 4.81. There you go. So now, if we want to use the Pythagorean theorem, we could use the Pythagorean theorem and to find the other side. You know, a squared plus b squared equals c squared. Also, I wanted to draw your attention to the way that I drew this particular triangle. This is not drawn to scale for what a 37-degree angle should look like. All right, so I want to see if anybody will notice that, or how do you draw your triangle. Make sure that you're drawing by according to ratio. So 37 degrees, this is closer to a 30, 60, 90 triangle. So it'll be something like this. All right, be careful with that. But yeah, but any triangle works. It's just a matter of, keeping your labeling correct. We have one more problem. Yay, and that's it.